All right, so our goal today is I can solve word problems with algebra. Okay, so you might be able to solve it different ways, but our goal is we have to solve them using algebra. And so this is the 7th lesson in this unit. So yesterday what we worked on is we worked on let statements. So this time we're going further in the sense that we can actually solve for our unknowns. So we have, in a sense, a few different steps. Okay, and we've been doing them already when we created our let statements. So first of all, we identify keywords, and that includes numbers, operations, variables. We draw a diagram if it will help, and it might help with some of our questions. We identify how many unknowns there are, just like we did with the previous lesson, and then develop a let statement for each one. Then we create an algebraic equation. Okay, so before we are doing an algebraic expression, this time we have an equation, so we know that the two sides have to be equal to each other so we can actually solve. Then we're going to solve that equation. Then this is something often that we forget. We're going to reflect on our answer. Does it make sense? They were asking for even numbers and I ended up with odd numbers. So what does that mean? Does it mean that there's no solution to this question, or did I make an error? Okay, so question 6 is important for us to look at. The same thing if I'm talking about money and I got 2.5 nickels. Well, can you have 2.5 nickels? No, you can't. So again, something's probably wrong somewhere in our solution. So the easiest way to work with these is do lots and lots of questions. So we're going to do a couple examples together. And possibly what I will do is I might make another video later on with some solutions to the ones that you've been assigned. All right, so the first one says the difference between two integers is 17. 9 times the smaller number is 69. More than 3 times the larger number. Determine the numbers. An awful lot of information. Too much for me to decipher at one time. Now, this has 3 sentences. So if I forget even about the numbers, I can see I've got 3 periods. I know I have 3 sentences. I'm going to look at both to get all 3 of them separately. So the difference between two integers is 17. Okay, so it looks like I have 2 integers somewhere. The next part says 9 times the smaller number is 69 more than 3 times the larger number. Okay, getting way too much stuff again. Okay, so it looks like first of all, if I go back to that first sentence, I have 2 integers. It appears that according to the next sentence, I have a smaller one and I have a larger one, which makes kind of sense. They both can't be the same number. So I'm going to let x represent, and I'm just going to put rep for short, the small integer. Oh, sorry, small number. It might not be an integer. Small number. And now when I'm looking at the next number, it's the difference between them. Remember we talked about the difference between, it's going to be 17. So how do I figure out that question mark? Well, it would be 17 plus the x. Okay, and I talked about that the last lesson very quickly at the end before I ran out of time. So we're going to let 17 plus x represent the larger number. Okay, so I have these 2 numbers. So what are we doing to them? Well, it says 9 times the smaller number. Okay, so my smaller number was x. So 9 times my smaller one is, which usually translates into equals, is 69 more than. So this is bigger than 69 more than 3 times the larger one. So I'm going to talk about that 69 in a minute, but I know that I have to do 3 times my larger one. Okay, I have the equal sign there, and it has to be balanced. If I do 9x, that means that 9 times the smaller number is more than 3 times the other. So I can't just put plus 69, okay, because plus 69 wouldn't have it balanced, because it says 9 times the smaller number is 69 more than. So I have a couple different options. I can either subtract the 69 from the left-hand side, or I could add 69 to the opposite side because I want it to be balanced. Okay, so often what I do is I do exactly what I just showed you. They talk about 9 times the first number, 3 times the other number, and then they have some other kind of relationship. In this case, 9 times the small one, it's bigger than the other one. So that means we're going to subtract. Okay, so now that I have my equation, notice the equation has an equal sign, I can actually solve this. So let's go through this. And the first thing I need to do, I can't do anything on my left side, so it's going to say the same. The other side, I'm going to do the distributive law, so 3 times 17. So we're looking at 51 plus 3x. I want to get all my x's to one side, so I'm going to subtract 3x from both sides. So I end up with a 6x minus 69 equals 51. Then I am going to add 69 to both sides. And when we do that, we end up with a 6x equals 120. And almost done here. Well, then I would divide both sides by 6. And when I do that, I have x equals 20. Now, am I finished? Well, the question asks for 2 numbers, and all I have found is 1 number. So now what I need to do is I need to go back and look at the let statement. So go look at let statements. And when we do that, you can see if I go back here, it says, here's my small number, my larger number is 17 more than that. So what I need to do then is, so that's a small one, so I know my large one is equal to 17 plus x, so I know that is 17 plus 20, so it is 37. Now, just to finish it off, I would then put a therefore statement. Therefore, the numbers are 20 and 37. All right, so let's do one more example together. Hopefully we have time to get that in. All right, so Haley has 50 coins in her piggy bank consisting of quarters and dimes. After adding them up, she finds that she has $8. Determine how many quarters and dimes she has. So she has quarters and dimes. So a couple different things here. This is a money question, and usually with money questions, I'm interested in 2 different things with my let statements. So when I'm talking about money let statements, usually I have the number of coins or dollar bills. So I have the number, but I also have the value. Because when we're talking about money, money has value. Okay, so we have a couple different things going on here. So Haley has 50 coins. So it means that if I add the number of quarters and the number of dimes, they would add up to 50. Okay, and after adding them up, she finds that she has $8. So my number of coins comes from the first sentence, and the second sentence provides me with the total, provides me with the value of the total. So the first thing I need to do is obviously make my let statement. So we're going to have let, and does it matter which one X represents? You know, we have dimes and quarters. I guess it doesn't really matter. I'm just going to, because quarters is listed first here, I'm just going to let X represent. And remember, it's the number of quarters, not the value of the quarters. Okay, because I know how much 1/4 is worth. It's worth 0.25. Okay, so X represents the number of quarters. Then what am I going to do when it comes to the dimes? Well, we've done this before. Okay, so if I add the two of them together, it equals 50. So I know I'm going to let 50 minus the X represent the number of dimes. Sorry, it's a little sloppy there. All right, so let's take a look at this. So there's my let statements as far as the number of coins. Now I have to look at value. So the let statement gives me number of coins. The value is going to get the rest of mine, because they tell me that if I take the X's and the number of dimes, and if I add those together, I'm supposed to have $8. Okay, so $8 is value, but how much does each quarter, how much is it worth? What's its value? Its value is 0.25. The value of a dime is 0.1. You can put a 0 if you want. Okay, so if I take the number of quarters I have, multiply it by 25 cents, and I take the number of dimes I have and multiply it by 0.1, if I add all that amount together, I should have $8. So now we're finished actually making our equation. Now it's just a matter of solving it. Okay, and again, the more you do as far as questions, you'll start to notice a pattern. So almost all money questions are like this. Okay, so we need to do distributive law, 0.25x plus, okay, we have 0.1 times 50. So what does that equal? Well, I think that you would find that that equals 5, and minus 0.10, x equals 8. Okay, we have x's, they can go together. Okay, so this, I'm subtracting 0.1 x's, so I end up with 0.15, that's a 0 by the way, x plus 5 equals 8. Now I'm going to subtract 5 from both sides, and I'm left with 0.15x equals 3, and I divide. Now, if I get a decimal for my final answer, I know I've done something wrong. So x equals 20. So what does that mean? Well, it means I have 20, and x stood for quarters. So that means I have 20 quarters, so now I need to find the dimes. And I can go back to my let statement, and my let statement says 50 minus x. So 50 minus x. So I know that that is 50 minus 20, which equals 30. Okay, so even though you can do this, most of you can do this in your head, I need to see these steps, okay, because that tells the person looking at your solution that you know exactly what you're doing. And so now I need a therefore statement. So therefore, she has, that's a funny therefore statement. Therefore, she has 20 quarters and 30 dimes.